in preparing this project, we took a couple of steps to make sure that there's no point in suing us.
Okay, thank you.
Just a brief comment in regard to the previous questions concerning GSM-R and Tetra. First, GSM-R, at least voice-wise, there is no difference to standard GSM. GSM-R has some very neat features like functional addressing, call priority, etc., but as far as these components are concerned, it's essentially identical to GSM, so it's prone to the same issues. Mm-hmm. Second, Tetra, that is a completely different story because I mean, a plain Tetra network will not give you security that's worth being called by that name, but the various national implementations usually have some end-to-end encryption that is not always switched on, but it can be switched on, and if it is, then that's vastly superior to A5 whatever. Okay,
well, thanks for that input. That was news to me. I'd still like to repeat what I said earlier. If anybody has access to Tetra hardware, and I mean this seriously, even if you know that it's just implemented in the silicon chip, we want that hardware and we want to get this cipher out. It's just one more proprietary crypto system that hasn't undergone any public review, and that a lot of high security organizations rely on. We'd love to look at it and perhaps find that somebody has created good proprietary crypto. We haven't found a single example so far.
I wonder if the rainbow tables that are created in the community have to be protected against manipulation, or is that not needed? And if that is not needed, then why?
It's actually really quite trivial to protect against malicious tampering of the rainbow tables. All you have to do is just try and look something up in it. If you look something up in the table and you don't get a correct result, then there's something wrong with the table and you can just discard it. It's very easy to verify correct functionality of them.
Right, so to test a table, you have to test a very small subset and recompute it. And with just a tiny fraction randomly chosen, you will find tables that have a majority of junk in it. So there's no way of denial of servicing just by uploading tables that aren't real. But good question, thank you.
Just one precision on the railway GSM usage. That was introduced because there's some kind of very stringent regulation, so that, for example, you need to call a train and have a connection delay of at most a few milliseconds. So in order to achieve this kind of good performance, they removed some optional part, which is encryption and authentication. So for emergency calls to train, they are not encrypted and not authenticated, and you can look in the UIT or ITU specification, it's documented there. So just verify.
We have also heard hearsay that encryption is required to be optional in GSM handsets, at least in the US, specifically so that law enforcement can turn up outside your house with an IMSI catcher and listen to your cell phone calls.
Oh yeah, one information we didn't give you when we were talking about IMSI catchers. An IMSI catcher is trivially detectable from the network side as well. So the network operator in any given country knows where IMSI catching is happening. Do they care? Do they call the police to tell them that the police is just pulling off an IMSI catcher? Of course they don't. So the network operators choose to not care as well. As I said, everybody in this food chain chooses to leave you as the user as uninformed and as unprotected as they can possibly get away with.
And at the same time, if you ask the network operators about the security of their networks, they will absolutely swear until the day they die that they are secure, that GSM traffic is secure, cannot be intercepted, as good as a landline. In reality, it probably is as good as a landline in the States. Thank you, AT&T.
Yeah. And they don't just publicly try to push this as a security technology, but more hurting to the overall security in new system developments, new payment system, new banking applications. Many of them consider using GSM as a trusted channel between the user and themselves, which is a terrible idea, especially given the option of doing application level encryption, these being data applications. So yeah, there's a lot of nonsense about the security of networks being said by the network operators. And I sometimes wonder if they really believe that themselves to any degree. Another question?
Yes. So if it is detectable, when do you think there will be applications for smartphones that can be installed that will access the available data and then alert the end user of the current phone status?
The biggest problem with that is that it's very difficult to get baseband information out of a cell phone into user land. Generally, cell phones will have at least two processors, one to run Android or whatever operating system is running, and then a completely separate processor to run the baseband. And they'll just communicate over a standard serial link with a standard AT command set. So there are some phones, like some Blackberries, if you can expose the engineering menu on some Blackberries, you can expose some of the baseband information to user land, and you can write an application to parse it. In the majority of phones, though, you have absolutely no insight into what's going on in the baseband, so you'd have to find some kind of backdoor into it, some kind of side channel maybe to try and find information about the call and about the network status. So in theory, it's possible to do on any phone. In practice, I think the only handsets that we're reasonably confident you could do it on is the Blackberries with the engineering menus.
Yeah. So the short answer is we're the wrong people to ask. That the handset manufacturer would have to choose to implement such a tool, or at least to expose the data needed. There won't be an iPhone application detect IMSI catch, since that application doesn't have access to the data yet. There's some iPhone people here, I know. Maybe we can talk to them.
Yes.
Can you talk some more about detection and what the baseband would need to be looking for to do that? How it can be detected?
I think the primary thing for it to look for is a lack of crypto. If you're connected to a network that has asked for you to use a plain text connection, that should just be an immediate red flag.
If you have seen the same network use crypto before.
Yes,
about half of the networks in the world do not use crypto. Half of the networks in the world. Yeah, but there's a long list of red and yellow flags you could look for to detect an IMSI catcher. Anybody who has access to baseband information, I'll be happy to share that list and create an application with you on any phone, really.
There's a lot of signs. OpenBTS isn't perfectly compliant with the GSM spec yet, so you could detect it from the protocol. I mentioned the clock on the USRP is not particularly stable, so the clock that we've added is better. It does bring it within the tolerances of the GSM specification, but it's still not as good as the clocks that you'll get from actual, legitimate base stations. So there's lots of side channels, lots of direct channels as well for detecting the attack.
We're through with the questions, okay. I take it?
I think we're out of time.
Again, so thank you very much.
Thank you very much.